Okay, so we're going to consider the parametric equation x is equal to sine of t and y is equal to cosine of t. So what this means is if we choose t values and plug them in here, we would get an x value and a y value. Okay, so I could pick a variety of different t values. I'm going to pick ones that kind of make sense. And then I'll calculate the y value. So if I pick 0, pi over 2, pi, 3 pi over 2, and 2 pi, I'm going to plug those t values in. They're going to give me x and y values. And then I can end up with those ordered pairs for x and y that then I would go ahead and plot. So if I plug them in here, I would plug in 0, so the sine of 0 is 0. I would plug in 0 over here, the cosine of 0 is 1. So the ordered pair that I would plot for t equals 0 is 0, 1. So if I plug in pi over 2, the sine of pi over 2 is 1, the cosine of pi over 2 is 0. If I plug in pi, the sine of pi is 0, the cosine is negative 1. If I plug in 3 pi over 2, the sine of 3 pi over 2 is negative 1, and the cosine is 0. If I'm back to 2 pi, I've gone one full complete period, so then I would be back to 0, 1. So now if I were to go ahead and plot this, I would be looking at something along these lines. So if this is 1 and 1, and this is x and y, I'm going to start here at the point 0, 1. So x has gone 0 and y has gone 1. So my first point would be right there. My next point would be 0, 1. So x is 1 and y is 0. And then I would have 0, negative 1, 0, and back to 0. Okay, so I'm going to go ahead and connect those. It should make a circle. Okay, if I look at this, I could plot some more points and I would see that they're not straight lines between them. And then because this is a parametric equation, I do want to indicate in the direction in which that parameter was increasing. So that's going to go ahead and mean that I stick arrows on here in this direction. I started at this point and I continued around this way. So you can see that this turns out to be a circle if I've defined x to be this and y to be this. Now, if I want to eliminate the parameter, okay, that means that I want to go ahead and have a relationship between x and y that doesn't involve t. Okay, now I kind of know what I'm looking for here because I know what the equation of a circle is, but even if I didn't, that's okay. So we know the identity sine squared t plus cosine squared t is equal to 1. That's been established in previous chapters. Now if we look here, we can see that we have defined x to be sine of t. This is different than the definition when we first found these. We're just saying that in order to get the x value for this graph we're making, we're going to plug it into sine. So that means here instead of sine, I can write x squared. Okay. Here for cosine, I've defined y, the y coordinate of this graph, to come from cosine of t. So instead of cosine, I can write y squared, which is equal to 1. So you can see that this equation right here describes this graph or this circle and doesn't involve t. So I have eliminated the parameter.